Hey, welcome. We are live in period two. Just a reminder, if you want to be on this, say stuff. If not, then wait until the end and I can answer any of your questions, okay? Today we're talking about area of circles. Woohoo! So we've got a big formula right here. A is equal to pi r squared. We're going to be using a form of this or some form of it at some point throughout the notes. If you don't have your notes out, I highly recommend making sure that you get them out here. All right. First question is just basics of finding the area. So with area, we need at least the radius. So in this case, it gives us the radius of this little stopwatch here. And we want to find the entire area. We would just plug that in. So area is equal to pi times 1 5/8 squared. Now here's the deal. 1 5/8, that might be a little bit tricky to do. So in your calculators, you might want to just plug in first what 5/8 actually is. So if you go ahead and do that, you'll have the area is equal to pi times that 1, and then the decimal, which is 6.25 squared. Now, I won't lie to you. One of the number one mistakes of students is they multiply pi and then the 1.625 together, and then they square it. No. You don't want to do that, okay? You want to square first and then multiply by pi. So if I'm just going to write this all out for this example in particular, this would be pi times approximately 2.64, and then area would be equal to approximately 8.3 inches squared. Okay, got to make sure that you have that label on that. But the big thing is making sure that you square before you multiply by the pi. I see Algebra 2 students do it even. I was just going over an exam with somebody. They ended up multiplying first before squaring. No, don't want to do that. Okay. Number 2, find the diameter. So if you are finding area or you have an area and you want to work backwards to find a diameter, well, diameter is not in our formula. But, okay, we should know that diameter is really 2 times the radius. So if we can figure out what the radius is, okay, find radius first, you should be able to find the diameter. So let's take a look at this here. We've got area is equal to 2 pi r. I'm just going to write the formula. So I've got 28.3 is equal to 2 pi r. I'm going to divide each side by 2 pi. That way I can get the r by itself. And r is going to be approximately 3.00. So 3, essentially. Okay. Well, with diameter being 2 times that, then I can just say 2 times 3, which would be approximately 6 centimeters for my diameter. Remember, radius is from the center to one side. Diameter is from the center to both sides, from one side to the other while crossing the center line. Questions so far? Yeah.
Why do we use area equals 2 pi r instead of area equals pi r squared?
Is it pi r? You know what? I messed that up. I did mess that up. You're absolutely right. I owe you a sticker. I was thinking about circumference. Sorry, guys. My math was right, though. This should be, well, except for this. I apologize. I'm getting ahead of myself. This should be pi r squared. So then this would be pi r squared. We have to divide by pi. My answer was correct. And then we'll have 28.3 over pi square root both, and then you should get still that r is approximately 3. I'm sorry. I owe you a sticker. Hannah, come on up. Now that messes up my video. That's okay. If you guys know my mistake was there, then hopefully you fast forward through it. Yeah. All right. Area of a circle on the coordinate plane. This formula will help you determine the area of a circle on a coordinate plane. The H and K are the center of the circle, and R is your radius. So just kind of throwing it out there. Here's an example. If I had like x minus 4 squared plus y minus 3 squared equals 49, my center would be 4 comma 3, and my radius would be 7, because 7 squared gives me that 49. Okay, so you'll see a lot of problems like that whenever they're in this form, but it's not the last time that you'll see this, because example number 3 and example number 4, we're going to go over both. Example number 3 says graph the circle. X minus 3 squared plus y plus 2 squared is equal to 16. Then find its area. So first thing we want to do is we want to find out where the center is. So the center in this case is going to be our 3. And then notice how this isn't a minus. This is actually like saying that I have minus negative 2. So my center is going to be at 3, negative 2. And radius, does anybody know what squared would give me 16? Ashley? 4. Good. My radius is 4. So I'm going to go to 3, negative 2. I'm going to put a dot, put a point. And then I'm going to go from there. I'm going to go up 1, 2, 3, 4. I'm going to go down 1, 2, 3, 4. I'm going to go to the right 1, 2, 3, 4. And the left 1, 2, 3, 4. And then I'm going to do the best of my ability of just draw a circle. Okay. Last thing I want to do, and I learned from my mistake, area is equal to pi r squared. There you go. Got to flip my brain from the circumference we were doing the other day. And then I want to plug in my radius into this in order to find my area. So A is equal to pi times 4 squared. So area is equal to pi times 16. So area is approximately, double check me, I've got 50.3, and then we'll just say units square. Cool questions? Yeah, I'll scroll back up for a second. This one. And then try example 4 on your own. See if you can do it. Those of you that are watching the video, you know that anytime during this video, you can always pause, fast forward, rewind, or so forth. This video is brought to you in part by math students. They're everywhere. Yes. Go back up to example 2 here. I've got a student that needs it.
So this is 1440. Does that mean that's the interior angles?
The sum total of them. Yes. So all interior? Of them. Yes.
Okay.
Yep. Again, you should hopefully be working on example number 4, which I'm going to pop up here in a second. Okay. All right, let's take a look at example number 4 here. Graph the circle, then find its area. First thing that we want to do is find the center. So I've got negative 4, comma 5. And then the radius. Now remember that original formula, the reason that that's -4 is because the original formula says x minus. So really this is like minus a -4 there. And then the radius is, anyone know what that would be? 6. What square gives me 36? 6. So I'm going to go ahead, I'm going to plop over here to -4. 5, 1, 2, 3, 4, 5. And then I've got 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm going to do my best to make a circle. Okay, if it looks like something that you wouldn't drive on, that's okay. We're not artists. Doesn't have to be perfect. That almost looks like a baseball diamond. Now I've got it, my area. So area is equal to pi r squared. So area is equal to pi times 6 squared. Remember to square the 6 first. So then area is equal to approximately 113.1 units squared. That's what I have in my notes. So most of that work was mainly on finding the whole entire area or finding the radius or diameter. What we're going to work on next, and this will kind of be like the last things that we really touch on, is how to find areas of a sector or a fractional area of a circle. And a lot of it has to do with the measure of 360 degrees. Very similar to what we did with circumference, on how if we wanted to find a small piece of circumference, we found out what the degree was, divided by 360, and then that was at least our sector or a piece. Very similar with area as a fraction. So it's almost like taking literally a slice of the pie. So the area of the sector, the formula would be the measure of the angle. So the measure of the angle of AB divided by 360 times pi r squared. So if we can find out what the degree is, divide by 360 and then multiply by our area formula, then we should be good in order to find that slice of the pie. Let me take you through example number 5. Now, example number 5, it kind of gives us the smaller sector first. You know what? I'm gonna, let's do example 5. Example 5 says find the area of sector formed by angle HJK. So what our question is asking us first is what's the area of this piece? But in order to do that, I feel like we should probably find the area of the small sector first, or we could find the area of it. If we take 360, let's do this. Let's take 360, let's subtract 100, and we end up with 260 degrees. So this whole entire section is 260. Now that we know that, we can plug that into that formula. We've got the measure of angle HJK. I'm just rewriting the formula over 360 times pi r squared. So the area, the measure of the angle is 260 degrees over 360 times pi times 12 squared. Which then we can plug into our calculators in order to solve. So if I'm plugging this into my calculator, chances are I'm probably putting the 260 divided by 360 in parentheses, and then times pi times 12 squared. which should give us approximately 326.73, and then it looks like just units squared. I don't know if my calculator will load, but could somebody fact check me on that? Make sure that I did that correctly. I'm good? Okay, thank you. Just want to make sure that my calculations, I do everything ahead of time, but you never know. I'm like you saw earlier in this video, I make mistakes. Example 6 says use the diagram to find the area of Q. Okay. So here's what it gives us, and here's what we know. The area of the shaded sector is 48 feet squared. So that means that this entire area here in yellow is that 48 feet squared. What would I need in order to find area in the formula? What two things do I, or what one thing do I usually need? Connor? Radius. I need to find radius. So here's what I'm going to do. I'm going to take and look at the area of the circle, try and find some type of radius if I need to. But you know what? That radius is actually already calculated in that 48. I don't think I'm going to need it. Let's plug in what we know. Let's do this. Let's just start off with our basic formula. Area is equal to, what would it be? It would be the measure of RT over 360 times pi r squared. Because this right here represents my total area. That's what I'm trying to find. So I might not need to find my radius in this case if I solve, because really if I find that whole entire thing based on what I have, then I should be good. So this says here that 48 is what my shaded region would be, equal to 120 over 360. And then I'm going to convert this. I'm just going to say that this is times my total area, TA. So now let's solve for my total area. Let's multiply both sides by 360. And then let's divide by 120. I need my calculator for this one. 360 times 48 divided by 120 gives us a total area of 144. Questions at all? This is very similar to what we did with circumference the other day, actually, where we were given a small chunk, then we had to find the total circumference. Last time is 8:38. I think we can finish up the video. Find the area of the figure. Yeah, we can do this. We got this. All right. Find the area of the figure. First off, we've got two different figures. We've got a semicircle and we've got a triangle. So area of a triangle is area is equal to 1/2 the base times the height. Okay. And then again, you've got the area of a full circle. A full circle would be pi r squared. So a half of a full circle would just be 1/2 pi r squared. So I guess a couple things that we need to probably know. We need to know the radius. So we know that the diameter is 7. So the radius is half of that, which would be 3.5. So area is equal to 1/2 pi times 3.5 squared. So this would give us a semicircle to be approximately 19.24. Then we've got the triangle. Area is equal to 1/2 the base. Now our base in our triangle could be either one of these sides. It'd be, in this case, it'd be 7. And then our height could also be 7 as well. Because this is a right triangle, and it's equilateral, they are both the same. So 1/2 of 7 times 7, which is going to give us 24.5. So now let's add those two together. Oh, hey, thank you. All right, let's go ahead and add those two together here to give us a grand total of approximately 43.74 meters squared. Questions at all so far? I know it's great stuff for a Friday, guys. Thank you for holding on with me. Last two here, we've got find the area of the figure. What we're trying to do is we're trying to look for the shaded region. This looks super difficult, but it's actually pretty simple because you only need two things. You need the area of a rectangle, and then you need the area of a circle. So first off, the area of the rectangle is length times width. So 18 times 6, which is 108. And then you need the area of a circle. So pi r squared. Now take a look at this picture. What is r? Running? 3. Good. 3. Okay, if this is my diameter, then r would be 3. So 3 squared. So let's get that here. That's going to be, I actually didn't do those calculations. Everyone get it? No? Okay. It'd be, let's just say here so far, pi times 9. Nobody's saying anything, so we'll do 9 pi. Finally got a calculator. So 28.3. Let's do 28.3. And then we have 3 circles. Three times. Whoa. So that would be 84.9. So now, because we've got 3 circles, we've got 2 full circles, 2 half circles, which would give us that third one. So now we want to take 108 and subtract from 84.9. Which will give us approximately 23.1 feet squared. The last example here that we have is a little bit of an extension problem. I'm going to turn the video off. This is pretty much it for the notes. I'm going to let you guys work on this for the remainder of class. Those of you that are in the notes, thank you for stopping by. We appreciate it.